Hi, my name is Wojciech. I'm here to present air quality monitoring system. Air pollution is the issue we are struggling for some time now, and it's still growing. During redevelopments, such as building new supermarkets, the main priority is to actually keep the flow of the traffic at the same or similar level, which means travel time from point to point. There is no mitigation at the moment for the pollution caused by increased traffic. This project will provide tools which could monitor actual levels of the air quality and be used as the factor for future developments and not use estimates. Over here you can see air quality sensor, which is composed around Arduino Nano with real-time clock, carbon dioxide sensor and the LoRaWAN connection, and is powered by the battery. It is small and it can be even further reduced by using just microcontroller instead of the Arduino and custom PCB board. This would extend the life of the battery. Based on the previously seen prototype, we had to recreate its behavior in the software, which is Node-RED. It allows us to create nodes, like you can see over here, which act as the actual sensors, which data is then sent to the gateway and is inserted into the database. Each node represents one sensor, and the orange one represents area and essentially gateway, which is used to insert the data into the database. Each sensor got hard-coded information in JSON format, which would imitate the actual device, which includes name, GPS location, hard-coded area, and particle per million, which is the value of the pollution. By the default, it's at the 0 because the range of the pollution is added later on in the payload, which then is inserted into the database. As we can see over here, it's the data inserted into our database, which is MySQL in this case, which it's running on the local server. However, we can use any cloud provider to host our database. It not necessarily need to be MySQL, as long as it can hold information we need. For us, it's the name, GPS location, particle per million, date, and area, as mentioned before. So over here, it's the dashboard, which is using the previously mentioned data. And as you can see, on the top there are cards with the statistics, with total areas covered by those devices, how many devices there are, average CO2 in Birmingham in one day, highest and the lowest reading, and which database the data is coming from. Just above there's date range. We can choose the dates we want data to be read. Over here you can see interactive map for Birmingham. However, it extends to whole world if you wanted to. This overlay it's produced by merging GeoJSON data of the worlds and their borders with our data. So average ppm for the given area could be displayed, as it can be seen. WHO got some recommendations about CO2 levels and how those supposed to be grouped for low, high and medium range. By using those guidelines, the pie chart representing the areas and how those they fall in those categories. As you can see, 23 of them in the low category and 10 it's in the high. Just keep in mind this is still artificial data. Just below we got area summary, which is the given area, which we can choose from a drop-down menu, and all the working sensors over there with the high, average and the low readings. As you can see, it does vary from sensor to sensor. Important thing to notice is when we change the date in date range, the graphs will be updated from that particular range. So for example, we got Hodge Hill and the date is from 7 March to 7 May, and 142 its value of 5 and the highest is 59. But if we change it to 11 of March, those are changing and the value is 29 for the high and for the low it's 20. The same, it does affect the others. Our last feature is live data stream. It takes CO2 values from the survey and it's displaying it as the line graph every 2 seconds. We can hover it to see the name, the date, as well as the particle per million at given time. Using this, we can compare it with the historic data of area. So by changing the date, let's say to March of 11th, and choosing Hodge Hill for example, we can see the values for the low was 30, average 35 and the high is 39. So let's add that sensor, the line graph, and it's updating. Yep. And over here we can see that ppm it's at 54, 58, 59, so that's the increase. Also we can add and remove any working sensor at any time, so adding more it's not an issue. The same with removing, and the graph will update itself. So in conclusion, even if this software right now is using artificial database, it can be changed to real one and it will remain functional and show the same kind of statistics as during this presentation. Thank you for watching.